Now, the concept behind horizontal and vertical asymptotes is this. What we're going to do is we're going to have a series of numbers here. So we're going to do 1, and then we're going to do equals this plus 10. So we're just going to add 10 and do that a lot. Okay? And then we're going to do 2 divided by this number. Okay? So, 2 divided by 1 is 2. 2 divided by 11 is 0.18. 2 divided by 21. And so what we want to look at is what happens to this equation, 2 over x, as x gets really, really large. That's our question. Does everybody see the question? So what's happening to this number as it gets closer and closer and closer to 0? Or as it's getting bigger and bigger and bigger? So what happens? Well, it starts at 2, then it's 0.18, then it's 0.09, then it's 0.06, then it's 0.04, then it's 0.039, 0.032, so forth and so on. So as this is getting larger and larger and larger, right, what happens to this thing? This is getting smaller and smaller and smaller and smaller. Now notice this. It doesn't matter how big I make this. It will never be 0. Does everybody see that? It will never be 0. I can keep going on and on and on, and what's going to happen is it will just keep getting closer and closer and closer to 0, but it will never actually touch 0. So it doesn't matter how far I go. Now, understand that 1,831, while it seems like a really big number, is really pretty small. Right, Jonathan? I mean, you know, $1,000 is a lot of money, but not if you're Bill Gates. Then $1,000 maybe not so much. Like Oprah, she doesn't care about $1,000. Maybe she does, but whatever. That's just a really, really, really large number, but not super large. And notice what's happening. So horizontal asymptotes talk about what happens as this number gets really, really big. Now, really, really big, what do I mean by that? What I mean by that is you know what? I think I just broke the damn thing. As it fills in all these damn numbers. I think I broke it. Okay. By large numbers, I mean numbers like that. Right? Now, what's 2 divided by that? And probably Excel will still doesn't say 0. If you keep going, at some point it would eventually say 0, and that's just a rounding deal. So understand, horizontal asymptotes, what happens when x is really, 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 really big? That's what the horizontal asymptote is. Okay? So, now, here's the question. Here's the question. If instead of 2 over x, what if I say 2x over x plus 1? What if I say 2x over x plus 1? So what I'm saying is, this is 2 times whatever the x value is, divided by whatever this value is, plus 1. Does everybody see that? So at 1, what am I going to get? I'll get 1. If x is 1, this becomes 2 times 1 divided by 1 plus 1. So this is 2 over 2, which is 1, yes? Now, as x gets really, really large, what happens to that number? As x gets really, really large, what happens to that number? Let's take a look. Starts off at 1, then it's 1.83, then it's 1.909, 1.935, 375, so forth and so on. What happens as x gets large? It's closing in on 2. Does everybody see that? So this is the concept behind horizontal asymptotes. Horizontal asymptotes are what happens as x gets really, really large. Does everybody understand the idea of a horizontal asymptote? It's what happens as x gets really, really large. Sometimes, as you saw, it goes to 0. Sometimes, as you saw, it goes to some number like 2. And sometimes, there's not a horizontal asymptote at all. And what would cause that to occur? Well, what causes that to occur is something like this. What happens if instead of having 2x, we have 2x squared? Okay? So what we have then is something that looks like this. 2x squared over x plus 1. What happens with that? Let me show you. 2 times this piece. Screw that all up. 2 times this piece squared divided by this piece plus 1. Now, what's that going to approach? Let's take a look. What happens? It's just getting bigger and bigger and bigger. Does everybody see that? Yeah, it's kind of doubling, and that's there's kind of a reason for that too. But notice that it's not approaching any single number. What's it approaching? It's ultimately just going to keep getting bigger. For as long as I keep going down, it's just going to keep getting bigger and bigger and bigger. So understand what you should be observing. What you should be observing is simply this. Not that. What you should be observing is this. That sometimes the graph, as x gets large, and by x getting large I mean going out this way. Sometimes as x gets large, it approaches 0. And that looks like what we saw earlier. Remember the graph of 1 over x? Bless you, by the way. The graph of 1 over x. That graph approached 0 as x got really large. So sometimes it approaches 0. Other times, it will approach a number. Other times it'll approach a number. Take a look. Okay. So if I look at a problem like that, it would be equals 3 times this number plus 1 divided by 2 times this number plus 4. And what happens here? Let's take a look. Watch as it starts to approach a number. What numbers are it getting close to? It's getting closer and closer to what? It's getting closer and closer and closer to 1.5. So sometimes when you graph, it won't approach 0, but it will approach some number in the middle, and that will look like this. Y equals some number. And it will approach like this as it goes there. Now, it don't always have to go from the top. Sometimes it can come from the bottom as well. But it has to approach it as x gets large. Okay, so sometimes it'll approach a number. Sometimes it'll approach 0. And sometimes it just doesn't approach anything and just kind of takes off. Okay? So our question today, what we have to try to figure out is, what's causing it to approach 0? What causes it to approach some number? And what causes it to take off? And if I can figure those three things out, well, then I have a little understanding of what the graph is going to do. Does everybody understand the challenge for the day?